Now, r squared is the r value that we talked about earlier, the coefficient of correlation, raised to the second power. And this r squared value is the coefficient of determination. Now, since r squared is a proportion of variation in whatever the y variable is that's explained by the linear relationship between the x and the y, since it's a proportion, it's got to be between 0 and 1. Now, if you take the value of r, which is between -1 and 1, you square that, it's going to get a number between 0 and 1. So that's a way to look at it as well. Now please note that that squared relationship only relates to simple linear regression. If you go into multi-regression or other things, you will not get the same way to calculate it. So if you have the r value and you square it, it's not necessarily the r squared or vice versa. So here's an example of how an r squared would work. Alright, so here are some data. We've got cost of a pizza in given years, just a slice of pizza, and a subway fare in the same town over the same years. So our x value will be the pizza and the y value will be the subway fare in each case. So we have 1, 2, 3, 4, 5, 6 pairs of ordinal data. The correlation coefficient is found to be 0.988. So what proportion of variation can we find in the model? We simply have to square this 0.988. Now how we calculate that 0.988 as well as the actual value of r squared I'll show you now. Alright, the first step is to enter the x values into a list and the y values into a list. I typically will choose list 1 and list 2. Stat and enter for edit. Now I've already done so. So my list 1 values are all of the cost of the piece of pizza, and my list 2 value represents the subway token costs in row 2 here. So you want to enter that data, and then you want to run the linreg-t test, and you'll see that on there, but basically it's with all the other tests. Stat, arrow over to tests, and I'm going to go up because it's near the bottom. It's letter F on this calculator. linreg-t test. So it specifically needs data, and it knows it must be in lists. So I've got list 1, list 2, those are the values. My x list is 1, my y list is list 2. If you use other lists, just make sure that you change these values appropriately. The frequency remains 1. This is what we're going to be testing, and I'll talk about these two things in a minute, but the test we're running as always doesn't equal. Now, it's not going to change the r squared value based upon any of these three things, but typically you want to know if there is a correlation or if there is a slope as opposed to whether it's positive or negative, because the r value will tell you whether it's positive or negative anyway, so it seems of little use. I'll talk about this bit in a minute, but calculate is what we want to do. So let me scroll down to the end where we have the r and the r squared value. So the r value 0.9878 or 0.988, and the r squared value is 0.9757. So this number raised to the second power will be this number here. And that's how you calculate it using the linreg-t test. And here is a box output from the TI-8384, much like you can see here. Alright, now this one we stopped with the r squared, and the one I have up on the screen, up on my calculator here, it actually goes down to the r. Doesn't matter, you can take a snapshot of it at any time. But this is a very significant r squared value. So almost 98% of the variation in the cost of the fare can be explained by the linear relationship between the pizza and subway fare. So they're correlated pretty closely, it looks like. Now, talking about causation, it is wrong to conclude that correlation implies causality. That doesn't mean that it doesn't, but you can't necessarily just assume because two things are correlated that one has caused the other. Does it make sense to indicate that, you know, whoever owns this pizza place is saying, oh, well, the cost of a subway token went up, we can raise the cost of our piece of pizza? No, that probably didn't happen, and the city that runs the Subway probably isn't looking to Joe's Pizzeria and saying, oh, they've raised their slice a quarter, we can do it with the Subway token as well. So there's a correlation there, but there's no causation between those two. There's an underlying, or what they call a lurking factor typically. And the CPI, or the Consumer Price Index, which is the other thing noted on that chart, is probably what's causing both of them. You don't want to make averages. You want to take individual points. If you start using averages, you can't really tell the proper correlation between the two. And as we discussed in correlation, there might be a relationship or some relationship between the two factors. It just may not be linear. It could be logarithmic, exponential, parabolic, whatever.